Welcome! In this video, we are going to take a look at the Pauli Exclusion Principle. We've seen that hydrogen is the only element with one electron. All other elements have more than one electron. The periodic table groups elements by property, and those properties depend on the number of electrons. The atomic number Z gives the number of protons, and it also gives the number of electrons when the atom is neutral. The Pauli Exclusion Principle, named after Austrian physicist Wolfgang Pauli in 1925, is used for determining the state of a system or atom. It states that no two electrons can have the same set of quantum numbers. That is, no two electrons can be in the same state. The quantum numbers are N, L, Ml, S, and Ms, though S is usually omitted since it is 1/2 4 electrons. So we use N, L, Ml, and Ms to specify the state of the electron. These values are as follows. N starts at 1, then goes to 2, then 3, and so on. L starts at 0, goes to 1, 2, and so on until it reaches n-1. Ml ranges from -L to +L in integer steps, and Ms is either -1/2 or +1/2. A shell corresponds to the orbit specified by quantum number n. It determines the physical and chemical properties of the atom. The subshell is the set of states within a shell. Subshells are specified by quantum number L and traditionally use the letters S, P, D, F, and so on. Spectroscopic notation is used to specify the shells and subshells. N times L is used where N is the quantum energy number and L is one of the letters that corresponds to its value. For example, L equals 0 is represented by S, L equals 1 is represented by P, and so on. Examples of spectroscopic notation are as follows. For N equals 1, L equals 0, and 1 electron, we have 1s1. For N equals 1, L equals 0, and 2 electrons, we have 1s2. The maximum number of electrons in a subshell is 2 times 2l plus 1. We find this since Ml goes from -L to +L. So there are 2L plus 1 possibilities. We have from 1 to L, we have from -L to 1, and then one more for the 0. And there are 2 Ms values. So combining these two, we see they give 2 times 2L plus 1. The maximum number of electrons in a shell is 2n squared. This can be found using algebra. Most periodic tables list the ground state configurations for the elements. The lowest energy shells are filled first, and then the lowest L values for subshells are filled first. There are some exceptions, such as potassium and rubidium, as their S shells are lower in energy and filled before, say, a 3D shell. I hope this was helpful. Let me know in the comments section if you have any questions. Thank you for watching, and I'll see you in the next one.